So I realized I'm an incredibly broken person. I'm wearing a shirt that says "The spice must flow," and I got it for Valentine's Day, and I was really excited. And then just a few minutes ago, someone from the foundation just introduced themselves to me, and I got excited again. But it turns out they meant the Perl Foundation. So GitFlux is a workflow we've been developing at Infinity Interactive for managing branches. And specifically, we are doing it to ship releases to clients. So that's kind of how it came about and why some of the choices we made were made. One of the big important features of this workflow is that we can trivially remove pending features before they ship. So like I said, we do all this for client work, and I don't know if you have the experience of working with clients, but to put it lightly, they can change their minds sometimes. So it's important that we can also adapt our code to fit those needs. We want to be able to track exactly what's in production inside of Git. So my coworker Jake had a lovely experience a few months ago where we got that fabled 3 a.m. call from the client, and the main developer was on honeymoon, and everyone else is kind of away. So we had to kind of do some forensic analysis on the Git repository to figure out what was going on. And if we had this solid discipline system, then we wouldn't have that kind of problem anymore. We also need to be able to ship hotfixes. So again, if we have a 3 a.m. call, we need to be able to deal with that quickly. And if that involves a lot of work that doesn't need to be happening, then that's kind of a problem. So I Google image search for boat duct tape. You know, just a little fix on top of a boat. And we got this instead. Another important property of the system is we want to be able to develop features in isolation. And the reason for that is, again, we do client work, and sometimes they decide that this feature can't go out on the October release. We need to wait for the September release, which is a long time. So we have to be able to adapt to that. Another property is we like to do continuous QA. We actually have a couple fantastic QA engineers on our team, and we want them to have work to do. So we want to have them be able to QA our product as we're building it, as opposed to waiting until the very end. So Git Flux is based heavily on branches, of course, because it's Git. And there are several important branches that we use. I hit the N key, apparently that means go to black. Okay. So the master branch models what's on production. You do not commit directly to master. You do not commit directly to master. Instead, what you do is when you want to change what's on production, you merge some branch to master. And I'll talk about what happens when that happens. After you merge to master, you immediately tag that release with some kind of version number or maybe a date, and then you actually ship it to production. So the history of master is exactly the history of production. That's really nice, because it means you can do diffs and whatnot. So there's also this concept of topic branches, which is pretty common in Git. It's basically a small branch that you use to add a feature, fix a bug, change documentation, address some kind of issue in your ticket system. So for each of those, you create an individual topic branch. And one little trick we picked up along the way is put the ticket number in the name of the branch. And that way you have some context for why that branch exists, what it's trying to do. We also do that for all our commit messages. So when you use git blame and it says fixed, you can get a better sense of what was actually fixed and why, and who asked for that fix. Topic branches are intentionally short-lived. You don't keep them around very long. The next important branch is base, and that's the start of every other branch. Base starts from master, which means all of the branches start from the previous release. And again, this is because we do client work, and we need to be able to build out exactly what they want, as opposed to just kind of working on our own for a few months and then shipping it over the wall. We actually need to talk to the client and figure out what they want and what combination of features they actually want in the next release. So yeah, all of the topic branches start from the same base so that they don't interfere with each other. A lot of other systems, including probably the most popular named Git workflow, Git Flow, when you start a new topic branch, it kind of starts off where everything else was merged into, so you have interference. You can't easily remove a feature if other branches started with that feature. The base branch is responsible for distributing changes from one branch to all the other branches, and I'll talk about what that means in a bit. The next and last important branch is the release branch, and that's modeling what's the next scheduled release. So typically what happens is you start a topic branch off at base, you do some work on the topic branch, and then merge it to release. And you do not commit directly to release. And the reason is, we want to be able to rebuild release without a specific feature. So those are our main branches. So I gave this talk at YAFC Asia a couple weeks ago, and I was demanded that I keep some Japanese in the slides. So let's go. So I have this kind of experimental, like 7 or so slides that include maybe 1,000 transitions. So let's do this together. So we have time on the y-axis, and we have the master branch on the left. It's in blue, and we're starting from the previous release, which is 1.0.0. The first thing we do, these are really slow. The first thing we do is we create a base branch off of master. So that's going to serve as the basis for all of the branches that we create after, including the release branch. So the first thing we do after we branch base is we branch off for release. And then we talk to the client, we figure out what they want in this release. I start working on a feature ticket. So that's my green branch. I don't know if the colors come up. Yeah, that's fine. So that's a commit right there. I just started a bug fix. And then Steven comes along, he starts adding a new feature. So we're working in parallel on different branches. My changes don't affect his changes and vice versa because this is branches. Steven continues working and then he decides that he can merge his new feature in. And that goes into release. And then release is automatically deployed via Bamboo, which is kind of like Jenkins, to our staging server. And then QA gets a chance to interact with it. And while that's going on, I'm continuing to commit and making sure my bug fix is good and making it all work. And then I merge to release. So now the release branch is what the previous release was, plus my branch, plus Steven's branch. And then QA gets to it and decides, oh, that's not quite right. There's still this corner case. We need to continue fixing it. So I continue, and I add a new commit, and I merge again. So now we have these two branches, and they form the release branch. And QA goes through and says, okay, this is good, we can ship it. So we merge to master. And then immediately after merge to master, we tag it, and we actually ship it to production. And these branches, of course, still exist, but we don't need them anymore because we actually ship them all to production, so we can get rid of them. And then the only thing that continues on to the next release is master. Okay. Now another case where, so we have all these branches and it's not always clear what they mean if you just read them on the slide, but I'm trying to give you an idea of how they're actually used in practice. So the next example is when we need to distribute changes via base, so we'll talk about that. So we have this previous release we built, and again, we start a base branch, we start a release branch, we start the top branches. So this time I'm adding a feature. Okay. Steven starts fixing bugs, I'm continuing to add my feature. And then all of a sudden, Twitter shuts off their API, their 1.0 API. So my feature branch is now broken, it doesn't work anymore. So what Steven did was he fixed it so that it uses the 1.1.0 API, but my branch is still broken, so what do? So the way we address that is you merge that fix that has to go to all the other branches into base. And then from there, you merge base to all the other branches. So they effectively get the change for free. Maybe not for free. They get the change. So now my green branch has a yellow commit that fixes the problem. As another practical example of this, we had a problem where the test suite suddenly started failing one day. And it turns out that like 4 years ago, I created a test that produced a date so impossibly far into the future that it would never happen, which was like 2012. So that kind of thing broke our test, so we needed to fix it. And this kind of system is how we address that. So Jesse comes along, he starts a new branch, and because he started after the yellow commit was merged into base, he gets that fix already, so it doesn't need to do anything. Then we start merging to release because all these features are done. Then QA approves it, and it goes out to Perl. And again, we don't need these branches anymore, so we ship them, we delete them. Next, I want to talk about hotfixes. So a hotfix is an emergency unscheduled change. The previous two releases I just went through were scheduled releases. Typically, we try to release early and often, so maybe well, it's all relative, right? So GitHub releases several times a day, but for us, every 2 weeks is about the right amount of time for a release. But maybe something happens drastically that we need to fix right away. Again, maybe Twitter shuts off their API. So the basic workflow here is we branch off master, we make changes in that branch, we QA them right away, and then we merge to master. And when we're in this emergency rush, everyone has to help. Even you, Stephen. So when we're doing this hotfix, we ignore the base and release branches and the topic branches because those are part of the scheduled release, the nice orderly planned release. But this is kind of technical. But we have this model and we stick to it and it works well. So the first thing we do is we start our scheduled release. I already started committing. And then the client calls and says, production's down. Or more likely, Pingdom will notice and tell us, and then we fix it, and then we tell the client that production was down for a few minutes. So in any case, we end up with this time period where we're all scrambling to fix a problem. So the first thing we do is we create a hotfix branch off of master. We fix the problem, and then we QA it, we put it on staging, we QA it, and then we merge it directly back to master. And that fills the model without having to worry about committing directly to master, or actually even worse, just changing the code on production without even committing it. I'm sure some of you have experience with that, and it's never really fun. And then the hotfix is done, we shipped 1.2.1, and then we can continue working on the scheduled release. So we don't need the hotfix anymore because it's on production. And again, like when we had to change, we had to make a change for all the branches, we do it again with this hotfix because it's what's on production. So we want all of our branches to kind of reflect that. I have no idea how I'm doing it. I don't know when I started. Dan, where are you?
Right here. Keep going, you're doing fine.
I'm wondering if I should slow down, take a breath, put my sunglasses back on. Yes. I can't actually read them. Okay, so we end up finishing our scheduled release. We add whatever features we were planning, we fix whatever bugs, and then we merge it all back down to release, then we merge it back to master. So we ended up with the scheduled release plus this problem fix right there. So it all fits well within the model, and the model kind of is geared towards doing client work. And if you're doing something like a cpan distribution, I don't know, this might be overkill. I would say, actually, I would not do this for a cpan distribution. Maybe Moose, but for something with less than 1,000 users, who cares? I wouldn't do it for CPAN, but because with CPAN you kind of make the changes you want to make and then you ship it to CPAN, and make the changes you want to make and ship it to CPAN. With this, we have all this infrastructure to adapt to the client kind of asking us to do particular features or fix particular bugs in a particular order. So we need all this infrastructure to kind of help us manage that. Okay, so what does it look like if we want to rebuild release without a particular feature? So we start a feature and everything's good. So much faster, huh? Then we decide that that yellow commit is actually, sorry, we don't decide, the client decides. That yellow commit is no good. We can't actually include that on production because we would lose millions of dollars a second. We don't actually have clients that, those kind of numbers. I'm sure it exists. Maybe Amazon. So what we do is the first thing we do is we delete the release branch. And the reason we can do that is because we never committed directly to release. We know exactly where it started. And it's just a merge of all the topic branches that are done. So the next thing we do is we just create a new release branch. And then we merge whatever other branches that didn't include the back change directly into it. Now, what would have happened if the yellow commit was part of other topic branches? Well, then we couldn't rebuild release because those other topic branches would include that bad commit automatically. So that's why we kind of develop our branches in isolation so that they never interfere with each other. And that means we can quickly and easily and almost programmatically rebuild release without a particular branch.
Doesn't it ever happen that sometimes a topic branch does in fact depend on another topic?
Yes, in those cases we just merge them together, and then if you can't have one, you can't have the other. Yep, so it's a regular scheduled release after that, and there's no problem. The only interesting thing is that the yellow branch survives until the next release. And that could be, if the client decided we can't ship it yet, maybe they want to ship it in 2 months, so we might as well keep it around. So there's no real reason to delete it unless maybe it's too buggy to actually ship right now, or something like that. So you can keep it, you can delete it, it's up to you. So this is actually a point of contention between John and me. So he says that you should rebase the yellow branch on top of the new master. And I say you should merge the new master into it. And the reason I say merge is because it's an explicit action, whereas rebase makes it look like the yellow commit was actually made down here sometime. So I think it's made a lot. I think rebase in general is a good thing, but we just disagree on this one. So that's how we do releases for client work. This is called Git Flux. So we're doing it for Infinity. We're doing it on a lot of projects, but not all of them. Some of the client projects we do need like multiple release branches, and I think the system could generalize to that, but we haven't actually sat down and gone into details yet. But generally, we're happy with it, and hopefully, if it works for you, that's great. But if it doesn't work for you, that's fine too. You know, you gotta do what you gotta do. So, thank you for your attention. This is my dog, Moose. He's a crazy dog. Any questions? He's waiting. Oh, sorry.
Yeah, my question is about you, if it's called features, for you, can sometimes you just modularize the feature so you can just not ship it, maybe have ship it to
So you're saying maybe add a feature flag that says this feature is enabled, this feature is disabled, instead of removing it from the code?
Modules, and that feature does not build it in, or that's not shipping code or something.
Yeah, that's certainly an option.
But not as easy though, but right.
Yeah, so I would say that that's a great way to add a feature for some users, but if you're not going to have it for any users, I'd say that's just complicating the situation. It complicates the history because you have this feature that's not actually being used, and it adds code, and more code is bad, right? So it's another approach, and for some things it is the better approach. You have a question, John?
So when would you rebase?
I rebase when I'm pulling in changes from other developers. I forget the exact quote, but it's something like, don't rebase when other people can tell you rebased, basically. So this model works entirely with merges, and that's fine.
Yeah, we don't disagree.
Yeah.
You may think we disagree, but we don't disagree.
I just like trolling you.
That's
Any other questions?